Expand cos x about x equals pi over 6 and find cos 31 degrees to 3dp. Here's Taylor's series then, expanded about x equals a, the expansion for it, according to Taylor's series. So we're going to need the f dashes as with Maclaurin's, aren't we? So here f of x is equal to cos x, f dashed, well cos goes to minus sine, f double dashed, sine goes to cos, so that's minus cosine. F3, cosine goes to minus sine, so we're back to sine x, aren't we? And then F4, sine goes to cosine. So there's the first few terms. We'll need the f of a's, and we're expanding about pi over 6. So we need f of pi over 6, which is cosine 30, isn't it? So that's root 3 over 2. Then f of pi over 6, f dashed pi over 6 now, and put pi over 6 in here. Sine 30 is a half, so that's minus a half. F double dashed is equal to cosine 30 is root 3 over 2 with a minus, and then F3, we're back to sine pi over 6, which is a half, and then f of 4, it repeats itself, doesn't it, as we've said before. F of 4 pi over 6 is cos pi over 6, and we're back to root 3 over 2. So that's what we've got then. So f of x is cosine x is equal to f of a root 3 over 2 plus f dashed, which is minus a half, so that's minus a half, x minus the pi over 6, the a value, plus f double dashed, which is minus root 3 over 2, okay, x minus pi over 6 again. This time the f double dash is squared, isn't it? Over 2 factorial. F3 will be here, will be plus a half. X minus pi over 6 cubed over 3 factorial plus, and then the F4 term, root 3 over 2. It will be x minus pi over 6 to the power of 4 over 4 factorial plus. So there's all the terms then. So if we put in cos of 31 degrees, now we're working in radians, but it's easy on the eye to write 31 degrees, will be root 3 over 2 minus a half. Now this will be 31 degrees in terms of its radians. So radians, 31 degrees, let's see what that equals then. Radians will be a fraction of the circle multiplied by 2 pi. So it's 31 pi over 180 is next to 2's cancel. So that's 31 degrees. Now pi over 6 in terms of 180 is equal to, times scale up by 30 top and bottom, and we've got 30 pi over 180. So 1 degree is equivalent to the difference, which is just pi over 180. So that's what we need to put in these brackets. Pi divided by 180 minus root 3 over 2, pi over 180 squared over 2, wasn't it? Factorial, plus a half, bracket pi over 180 cubed over 3 factorial, plus root 3 over 2, pi over 180 to the 4 over 4 factorial, plus dot dot dot. So what have we got then? Let's tap it in the calculator, see what we get. So it's root 3 over 2. Let's start there. So root 3 divided by 2 is that term. Oh, root 3 divided by 2, that's the first term, minus a half, which is, we can write as 0.5, times pi over 180. Pi divided by 180, close bracket. So that's the second term, minus the third, which you can write as root 3 over 4, can't we? Minus the square root of 3 divided by 4 times by bracket pi over 180, close bracket, and that will be power 2, ground level, plus a half over 3 factorial. This is 6, that will be 12, so it's 1 divided by 12 times by bracket pi divided by 180 bracket power cubed, isn't it? So there's a cubed term. Now I've got a feeling that will be sufficiently accurate. So let's, because we've got pi over 180 is quite a small number and it's cubed, and we've also got a 12. So let's have a look what went wrong here. Just toggle back, we'll see where we are wrong. We'll run through all the things. Root 3 divided by 2 minus a half times pi over 180, that's fine. Minus root 3 divided by 4 times pi, that's fine. Here's where the term's wrong, isn't it? We've got to put a plus 1 over 12 equals 0.857. It was to 3dp, wasn't it? 0.857. And that was to 3 decimal places.